what is our value proposition from a MetaScale standpoint? We look at batch processing or for online transactions within mainframes, but specifically, we know that a good around 60% of the MIPS that are consumed by mainframes, for instance, is because of batch processing. The data is growing with a strong pace, and the companies can easily save 60 to 80% of their costs with modernization. That's a lot of money when you look into those things. In fact, we just recently took out a mainframe machine, and that saved several millions of dollars by taking out a machine, and well on our way of taking another mainframe machine out. So taking mainframe machines out, of course, saves a huge amount of money in software licensing costs. That's where the majority of the money is coming from in your savings. So we do the ETL modernization, database, data warehousing modernizations by moving the batch processing out, and also move the transactional data, which is mostly online. We use different approaches to modernize that as well. But the ultimate goal is really to be able to have cost savings in addition to the agility for the business. So how do we leverage Hadoop? Now, mainframes, we know one of the challenges with mainframes is the growing skill set. The folks who have been doing COBOL, JCL programming for the last 30 years are going to retire in the next 5-10 years time frame. Some of them are already retiring. And the skill set is becoming difficult. You read about COBOL, JCL in history books nowadays. You don't really get to learn them in school. And that skill set is shrinking very rapidly. So that also pushes another reason why we need to consider modernization at the mainstream enterprises that are, that are using anywhere from 10,000, 20, 50,000, maybe sometimes even 60, 70,000 MIPS. Of course, each MIP, we believe, the cost could range from $2,000, $2,500 to up to $7,000 a MIP per year. So that's when you look at the numbers really go up with the MIPS utilization, and moving the batch processing off from mainframes over to Hadoop, we found has been a really phenomenal approach, which has helped us save the MIPS costs as well as improve the processing windows significantly. And we'll go a little bit more in detail on that in a bit. So what are some of the advantages of Hadoop? Cost reduction, as we discussed. If you move the batch processing off of Hadoop, you're looking at significant cost savings. A typical batch job, which may be consuming 7.6 MIPS, let's say, is not going to take your 0.1 MIP because we take the processing out from mainframes. Performance, a job that might be taking 7-8 hours, a batch job on mainframes, the processing time, we bring it down to a few minutes. So it's like 10, 12, 14 minutes or so, which is a significant 10, 20, up to 50, 100 times of performance improvement. ETL is getting really complex today. If you look at many organizations, large organizations have copies and copies and copies of data. They make multiple copies of data. So by taking ETL batch processing out and employing the concept of Hadoop as a data hub, we have found phenomenal progress and success in those areas as well. And then again, some of the challenges we are finding as we interact with several organizations is the lack of awareness. That's one of the biggest things we find. People want to use Hadoop. They like to start a use case. Most of the times they just don't know how to, and what's the best use case to leverage Hadoop for. So, and what are the challenges of Hadoop? Hadoop is not a one-all solution. We don't believe Hadoop should be used in isolation or solve all the problems. We believe it must be part of an ecosystem. So you leverage the tool for its strengths, and use that opportunity to make sure that you're building an ecosystem. So we'll talk a little bit more about that in a bit. The solution is, of course, using Hadoop as a data hub, as we discussed, and our approach at from the MetaScale standpoint has been that building a referential architecture. So starting with a data strategy, build a thorough, well thought out data strategy. Don't need to necessarily boil the ocean. That's not advisable. You want to go incrementally, step by step, and more of a crawl, walk, run approach where you gain momentum after proving use cases. And the approach traditionally involves building that strategy and then moving the batch processing to Hadoop. Those are some quick early wins, saves huge amounts of money, brings quick processing improvement, as well as builds the agility and moves things to distributed, potentially cloud-based open source environment. Making Hadoop as a single point of truth, make it as a data hub where you don't get into the ETL nightmares, which organizations do. So that goes in incrementally as well. And transform the ETL to extract and load, and then transform the data as you need by different and various systems, and then put it back into legacy systems for consumption. So we are not necessarily saying replace systems. We are saying take the batch out, put it back in there after the processing is done. And retain within Hadoop the source files of the finest granularity. So now you have every bit of detail you want within Hadoop, making it your single point of truth and the source of data. So one of the things we will do is, after we have been through some of the information here, we'll go through some use cases as well to share how some of this is in production. So just to give you some numbers, for instance, and this is important information for those who are, hoping to leverage Hadoop. Today, within Sears Holdings, we started around 2.5 years ago with an 8-node Hadoop cluster. It was something of an experiment, if you will, and now you are looking at within next month we are hoping to have over 1,100 nodes in our clusters. We have over 7,000 production jobs running every day on our Hadoop clusters, and because of the inherent resilience built into the entire Hadoop ecosystem, our service uptime is over 99.9%. So 99.99% service uptime is just phenomenal. We have found significant improvement to our SLAs and performance. Several of our applications that we have moved over. Not just the batch processing, we actually went ahead and moved entire applications, some of them are really crucial applications such as item master and item data applications, over to distributed platform, which is a combination not only to Hadoop, because you're looking at batch processing plus online transactions here. It goes into an ecosystem of distributed environment where Hadoop plays a key central role, and then other systems peripheral to it. Some of the benefits I'd like to share with you includes, just within 13 weeks of effort, we saved enough MIPS to save incrementally year after year $2 million, and that just goes back to the phenomenal and astronomical costs involved in mainframe MIPS maintenance. Took out over 1,000 MIPS. While we are doing all of this, we are modernizing the code, because as we rewrite the business logic from COBOL JCL code, and for those of you who have the background in COBOL and JCL know that each job might have a program, a batch job might have 7, 8, 9,000 lines of code. When you move that code over to PIG Latin on Hadoop, for instance, that shrinks down to 150 lines or less. So you can imagine how much the life becomes easier when you are actually the maintainability of the code, the supportability comes right through, and you have 150 lines of code compared to 7,000 lines of code. So you're modernizing the code, you are improving your batch processing windows, which is 6+ hours down to 10 minutes or less, and leveraging the massively parallel processing of Hadoop. So one of the things that we do is provide the services where what we've done is train the mainframe programmers. You can imagine mainframe guys are really done COBOL programming, have a different way of doing coding compared to the guys who do coding on Linux, let's say. So we have these programs where we train the mainframe guys into becoming PIG Latin Hadoop coding experts. Let's talk about the architecture a little bit. I touched on it earlier that we believe that Hadoop must be part of an ecosystem. Doing it, it's not a one-all solution. We believe that when you have large, huge amounts of data, petabytes, many terabytes of data, we find that the Hadoop processing, because of parallel processing concept, is much faster compared to doing it in traditional databases. But when you're looking at relatively simple queries, then we find that Hadoop is still going to take time to set up with mappers and reducers, etc. So we find that in those instances, using a relational database is the optimal choice. So when you look at the best tools for the job, then it comes out to be an ecosystem where you use the right tool for the right problem. Large companies have very complex environments with transitional systems, etc. So it needs to be an entire solution kept in mind, and that's an important part because over the last few years since we have transformed, it's pretty sophisticated stuff. This is not to be taken lightly. It's not for the faint-hearted, really. You have to think through the entire strategy early on, so that you're not having to go back and re-architect your model, which, by the way, we learned the hard way in some instances. We have had our share of scars in the learning process, and we are hoping that it took us a long time to get to where we are. With the knowledge and experience we have now, we believe that and we have proven it with some potential with some of our existing customers, that we can do this much quickly now. So this slide shows the Hadoop ecosystem. This is, if you are familiar with some of the tech companies' architectures, it's very much in line with what you would see for Facebook or Google, where the entire Hadoop ecosystem and architecture is being used, with data sources coming in, and these data sources could be structured as well as unstructured or semi-structured, really, and then moving into the loading process and the operations with MapReduce, Hive HBase. PIG is our choice. We have evolved into using PIG for legacy modernization purposes, although many organizations, just like we did, start with Hive. We found that PIG was more efficient, was better for the purposes we were using it, so we have evolved into using PIG Latin on Hadoop. And then it goes into the access layers where we are able to then leverage the data for better insight and intelligent data information that we can use for making decisions and quickly. So this is a graphical way of showing the entire ecosystem moving from legacy systems, if you will, and proprietary systems over to the new modern data architecture, where you are leveraging the, moving from COBOL, JCL, and vSAM batch processing architecture, over to the Hadoop and PIG architecture. So some of the traditional approaches to mainframe elimination have, and then for those of you who have tried it before, know it very well that mainframe elimination have a reputation of projects that just are very complex and are failing all the time. There are so many organizations, mainstream enterprises, who have tried multiple times to get rid of mainframes. We've been hearing about mainframes are gone for a decade now. And they're still here, and they have some very crucial applications sitting on them, and they cost a lot of money. They prohibit the business to be agile, and there's a good reason for it, because they're very complex and they take a very much of a long time to do it. So you really have to understand what's the best approach towards doing this without bringing in disruption to the business. So you want to be disruptive from technology standpoint, but from business standpoint, our approach is that business doesn't even know or find out that something behind the scenes got changed with our approach of moving the batch processing off of mainframes or even other data warehouses to Hadoop. I think we all know that how many organizations are still using batch processing. That's the structured data, which is more than 50% in mainstream enterprises. And these jobs run, and they run a very long time, and they hog up a lot of MIPS. So those are some real pain points for mainstream enterprises, and that's why we believe that we are at a juncture where mainstream enterprises have such a huge opportunity to leverage Hadoop ecosystem and big data to really come up front and to connect with the consumer. So this is the mainframe batch processing architecture. This is for traditional, where users, it's a typical system where you have a batch job in mainframe is typically a string of jobs where you have input of data, and then a bunch of jobs that go in there for computational purposes, and then it goes out to the output. And here you have you see the batch processing is happening within the mainframe from traditional approach, which the data is then being sourced to other sources and other destinations such as the data warehouse or the external systems. What we do from our approach standpoint is we let the input be there where we have in mainframes, and then we yank out the batch processing. We look for the most expensive jobs that are consuming the most CPU, if you will. So the ones that are consuming the most CPU and MIPS, we pull that job off of the mainframes, and we ingest all of that data into Hadoop. We process the data on the Hadoop, and then after we process it, we put the data and the output back into the mainframe. So from the user standpoint, nothing would have changed. They would see the input going in and output coming out as it was before on mainframes. But behind the scenes, what we would have done is to take out the taken out the processing from mainframes and put it on Hadoop, which would have saved you a lot of CPU time, resulting in MIPS savings and consequently cost savings, and also shortened your processing time, a job that, the string of jobs that was taking 6, 7, 8 hours down to 15, 12, maybe even up to less than 10 minutes. So the overall bad job that would take, with the entire cycle would take around 8 or 10 hours, is going to be shortened to less than an hour, because it would be ingested into Hadoop. That would take some time, and then processed in Hadoop, which would take a few minutes, and then back into mainframes, which will also take some time. So and it adds up to an hour or less. So this slide shows the alternative that we developed, and I just spoke to it, where we, without taking any risk from the business standpoint, we are using the input, we are processing it in Hadoop and putting it back into mainframes. It's a very safe approach. So unless the output file matches with what it was from mainframes, it does not move into production. And by doing this, you're basically taking out the batch processing and saving the MIPS. This is one of the approaches we applied that resulted in taking out 1,500 plus MIPS and allowed us to take out one mainframe machine. So this was last year. We are well on our way to take out another machine following this approach, and of course moving the applications as well. So moving on. This slide shows the batch processing architecture with Hadoop, where we are pulling the data from mainframes. So you remember the batch job that was running on mainframe, the entire input and the computational and output on mainframes. Now the batch processing is now all happening on Hadoop with MapReduce-based batch processing, and that ingestion of data. Now, this was not an easy experience. This is something that we really had to figure out what's the best way to ingest the data, how do we put it into Hadoop most efficiently, and then process it and then move it back. So all of these questions had to be figured out, and those were some of the lessons learned for us. And on top of everything else, the data governance piece. As the maturation happens, when you have built the use cases and they're working, you start looking into the best ways to optimize it, and you come across some of the inherent challenges that Hadoop might have, or from data governance standpoint and architectural standpoint, that you have to really work through. That's one of the reasons why I was saying that it's really, it requires a lot of lessons to be learned, and it's not to be taken lightly. It is a pretty sophisticated system. So we'll move on to, so this is just another visual representation of the job that we just talked about, batch processing, moving the whole job flow, moving into the Hadoop piece with the sorting, the split, and this is where the mappers and reducers are defined, and mappers go in, and then it gets reduced again, and then it goes back into the applications and the data. So it becomes, so you're looking at Hadoop becoming the source of data. This is how you're moving all the data into Hadoop, making Hadoop as a data hub, and this strategy is really very creative, we believe, and something unique that we have come up with. So many organizations have played around with unstructured data, but we believe that we are unique and novel in a way of leveraging Hadoop and big data ecosystem for structured data and for the mainstream enterprises. So that's where we believe that using this model, not only are you making some immediate tactical cost savings and processing improvements, you're really going strategically by creating Hadoop as your enterprise data hub, because every time you do this kind of a movement where you are moving data into Hadoop, you are truly working towards your enterprise data hub strategy, not necessarily boil the ocean approach, but more of a incremental approach, gaining momentum with every project. You keep adding more and more data into Hadoop and source from it. So we'll skip this slide. This is more of the same, providing information. Some of the, this is for those techies who have worked on COBOL and experienced the code. This is a good example of a function where you are looking into the JCL, and with this code you would see that it took 45 minutes. This is actually proven that on A168 mainframe, it took 45 minutes to process these 500 million records, and we found that it took us less than 2 minutes. You see that it's 20 times the impact is from the performance standpoint running on PIG. And look at the condensed code we have on PIG. This is really short, so it's much simple. It's much easier for someone to pick up. And interestingly, what we found was when we were training our mainframe guys on PIG, Latin Hadoop, we found them to be able to pick it up fairly quickly. The difficulty they had was in grasping the concept of Linux. So that's where they had some more challenges. But PIG, they were able to pick that up really, really quickly because it was so intuitive and condensed that they were able to, and similar in some ways, if you will, that they were able to get a good hang of it. And now, next thing you know, they were working on a training environment, and then they were moving jobs that were mainframe jobs onto Hadoop.
All right, Aashish, we got several questions in queue here, so if you're up for it, let's take a couple questions. The first question is refers to structured and unstructured data. Hadoop is being used for unstructured data. How does it handle structured data?
Yeah, that's a really good question. Hadoop, anywhere you see where companies, especially tech companies, they're leveraging Hadoop for unstructured data, getting the clickstream data in, semi-structured or unstructured data with log files, sometimes even clickstream really coming in with you have Facebook or tweets or data that is like videos. That's completely unstructured data for which Hadoop was just really, really popular for, and that's how it all started. There's a lot of work going on in Hadoop community. Hadoop 2.0 just got released, which brings Yarn and many other functionalities with it. But what we we experienced was, and it really was an incident, it happened, that we started using it for structured and found that it was equally good on structured data too. So that's what led to the batch processing piece. And we found that, it allows us to really go from a batch-oriented mindset to near real-time mindset, where instead of taking hours and hours and overnight processing, you're able to get back to business or to the consumer near real-time. And now, in the Hadoop ecosystem and the big data ecosystem, there are many new tools coming up, like Cassandra, MongoDB, and that they allow you to be able to almost, be real-time. So the mindset is moving from the entire batch processing mindset to a real-time mindset, which is almost necessary. That's the direction we see that the industry is heading, where consumer is expecting us to be real-time with them.
Okay, great. And you kind of touched on this already, but how do you load data from mainframes into Hadoop?
So from legacy systems, let's say, moving data into Hadoop, it depends on what system you're bringing it in from. So we have multiple buckets defined, and we look at what kind of data is coming in. If it is, we find DB2 unloads to work really well if you're putting the data from mainframes DB2 into Hadoop. Scoop is really good. We find Flume to be really good. So it depends on what is the use case. So if you are bringing in data from, let's say, Teradata, some of the processing you have on Teradata that you want to leverage Teradata for its strength, and let's use Hadoop for batch processing purposes, you move the data from Teradata, we have custom scripts for it. And so what we do is, from MetaScale standpoint, we help our clients or customers with identifying the use case, and then using those scripts, whether it's custom scripts or some tools or some of the products that we have built internally, which allows us to move the data into Hadoop and process it.
Great. We have a few more questions, but let's maybe continue on with the slideshow, and then we'll get to the questions at the end.
Absolutely, Nate. So let's go into some of the use cases. This is where you look at how and what was the impact. What was it? How are we able to implement? And these are some of these use cases running in production today. As I mentioned earlier, we have over 7,000 jobs in our production Hadoop clusters running every day. We have over 6 petabytes of data on our Hadoop clusters. So that's fairly reasonably sized data. We have it. And constantly we are moving Hadoop into our archival system. So instead of using tapes or other archival systems, we are storing everything. We don't want to lose anything anymore. We want to put and dump everything into Hadoop, and it's available for accessibility. You can easily analyze the data. So those are some of the key points that are outside these use cases. These are business use cases where we looked into our pricing, merchandising systems, and were able to significantly improve our SLA time period. For example, this one that you see on the slide right now shows you that we have so many different, like 30+ data sources, billions and billions of records in input. We were having scalability challenges, and it was just something that we were unable to process because there were not enough hours in the day. Our SLAs, we were missing them on a regular period. The logic was really complex. So what we did was we did the same thing as we just discussed. We moved a lot of that mainframe batch processing over to Hadoop. As you see on the next slide, we moved a lot of processing through Hadoop, and we saw that our savings, you see huge savings, and these are directly related from our MIPS consumption. When you use fewer MIPS, you see immediate relief in your costs because your contracts would show the less MIPS consumption, and depending on how you have negotiated your contracts, it depends on step-down approach or dynamic reduction in your MIPS costs. but you would see those annualized savings, and these are year-on-year savings. So once you reduce MIP, it's really for good. We had very complex codes down, reduced to fewer lines, and our SLAs significantly improved. As I mentioned earlier, we haven't had any complaints on our Hadoop clusters which impacted our SLA. Now, I wouldn't say that we haven't had any challenges. Hadoop has a very strong built-in fault-tolerant system. But on an overall, I would say that SLAs haven't been compromised, and our system uptime has been phenomenally high. Another use case where we had some of our SLAs we were unable to meet. Now, some of these use cases I'm sharing with you are real business examples. For example, for Sears Holdings as a retailer, price optimization is a key function from merchandising standpoint. Price optimization allows you to look into affinity-based pricing as well as understanding what's the best recommendation for a price if you're leaving money on the table on a product at a store, and be able to give recommendations as to what the product pricing should be like. This is an important function, as I said, and merchandisers really depend on it. When you have billions and billions of rows of records and you have to process that much data, it comes to a point where you are unable to process it on legacy systems just because of scalability or because you are just unable to do it. And we all know business is moving to a point where they're saying, hey, I used to do it once a week, I want to do it every day now. Or I want to send price changes every few hours. So we are moving to a point where it needs to be much more dynamic. We need to be far more agile. And the systems are really prohibiting us. These are the real use cases where we took out those batches and moved them to Hadoop, really significantly allowing our business to be more competitive in the marketplace, in addition to saving huge money. So it's a win-win-win if you look at it, where from every way you are, you have a performance improvement, you have a cost savings, and on top of it, you're giving empowerment to your business where you can really shorten your response time and go to market or time to react or time to analyze. All of that comes into play. On top of everything else, you're positioning yourselves to become a data-driven and insight-driven retailing or organization and as an enterprise. And we have been giving a lot of retail examples here, but this is really applicable to just about any other enterprise in other industries. We are helping mainstream enterprises in healthcare, financial services, insurance and banking, high-speed trading, oil and energy. So we have folks that we are helping in various companies in various industries that have similar issues. I mean, Fortune 100 companies or large enterprises, we all have kind of similar issues when it comes to complexities and leveraging tools and systems that have been there for a very long time. Here we had DB2 tables, so we moved them just like before, and we saw a significant improvement. As we saw, they are running much faster. We have savings. The code is far more modernized. You would see it's shrunk, it's condensed, and we also source data into Hadoop. So a very similar trend, what I like you to notice is how in various use cases, you see the underlying benefits which are common across all the use cases, and where you are saving money, improving the performance, so on and so forth, as we discussed earlier. So in summary, you can reduce cost, huge cost reductions. So it can actually justify expanding your Hadoop clusters. You can go from 8 or 10 nodes to start, and you can really multiply that to much larger ecosystem just by showing the cost savings and then self-financing that effort, because you would be saving that money from the budget. So you can expect your finance team would be really happy to see those savings coming in. You can reduce the strain on the legacy systems and platform where you can leverage the legacy for what it's meant or really good for. Batch processing has a really good alternative now with Hadoop. You're truly revolutionizing and transforming your enterprise, moving the workload and making it more agile, right? So you are you're being able to respond much faster. Your go-to-market strategy, you're able to react quickly. You can look into the store-level information and make decisions immediately, almost immediately, instead of waiting for months when your batch processing is complete and a cycle which requires a few months before you actually make a decision to change inventory levels or product, add more products to the store level, because now you know there are consumers at that store who do the shopping for the product. So sales is typically a very good example where you have huge use case for Hadoop, and these systems allow us to do it. So you can bring in new revenue streams. Hadoop brings so much for traditional and mainstream enterprises that if you know how to leverage it right, we are, as retailers, as healthcare industry, as finance and banking organizations, have so much opportunity that we can truly, it could be a game changer for us. And organizations who are leveraging Hadoop, we know quite a few who already have plans on and would like to, and they just don't know what's the best way to leverage it. And that's where we help from MetaScale standpoint to find the use cases that bring the most bang for the buck. We believe that will benefit and have a competitive advantage in the marketplace, the organizations who do get ahead on the curve on this. Some of the learnings: dramatically reduce batch processing. You can retain and analyze all the data at a far detailed level. You don't ever have to get rid of your data. You don't know what the data might be used for, and it's so inexpensive on Hadoop platform. It's just unbelievable. It used to be, tape backups where you would have different archiving systems. You won't even be able to analyze that data instantaneously if you wanted to. Now you have a near real-time analysis opportunity for all the data you are housing into your Hadoop system. You have one of the major learnings we had was that Hadoop must be part of an ecosystem. It's not a one-all solution. So you don't want to go ahead and try experimenting with a framework if you are starting a POC. That's something that is fairly complex and requires good skills. And building Hadoop skills is not something easy, I would say. It's something that you really want to leverage the help of someone who can help you build the Hadoop expertise. It's not easy to come by. There's not a lot of it available in the market. From the implementation standpoint, you can significantly improve your production schedules, your SLAs, eliminate traditional ETL, really give way to more like an ELTT concept where you have your Hadoop being used as a data hub. And you can really process a very large data sets with improved user experience as well. We have developed quite a lot of tools. We have several products that are very unique and are in the process of, they are filed for patent. They allow mainstream enterprises to address their structured data. There are tools available for unstructured data as well. But structured data is where we find ourselves really unique, and we help with unstructured data as well. As I mentioned earlier, we move quite a lot over to our ecosystem that we built and the architecture. So these tools and skills that we have, we help organizations with, and we do like to caution that there is learning curve involved that organizations have to keep in mind. And considering that we have taken out capacity and workload off of mainframes, off of data warehousing solutions, etc., we have a lot of experience in saving MIPS, cutting costs, improving performance, building agile, nimble, and adaptable business. So you could truly serve your consumer and enable the business to do so. So some of the services that we offer from legacy modernization standpoint, and legacy modernization we call it because it's not just mainframes, it also is any proprietary systems. It could be, it needs to be an ecosystem. It has to be thought through from a data architecture standpoint. So we provide the assessment services. We come in and understand your architecture and see what do you have. Many large organizations and enterprises have just about everything you can find under the hood. You open it, you will find stuff that's available in museums. You will find stuff that's available in research labs. I mean, large organizations do all kinds of stuff, and they still hang on to it. So we do that assessment to understand how and what your architecture looks like, what's the current and future state architectures, as well as what are the biggest MIPS reduction opportunities where you can really justify and build a case for bringing Hadoop into your organization. By such a strong use case where you are saving millions of dollars, as I mentioned earlier, taking out a machine could save you several $1 million. In fact, I'll not having the liberty of sharing the exact numbers, but I can tell you that one of our implementations, we spent certain number of $1 million as an investment, and in return we got over 200% of payback, ROI, just because of MIPS reduction savings within that same year. And so if you're investing, let's say, a couple of $1 million, just hypothetical number, you are saving $4 million that year, and every year after that, year on year, your EBITDA savings, you will see those numbers. So you don't find that kind of ROI in projects so easily. So this is such a huge ROI for organizations. We do that assessment. We provide the MIPS reduction services. Not only do we provide MIPS reduction services, which is focused towards batch processing, we also completely migrate applications, which are a combination of batch and online. And that's the architecture we build for organizations depending on what makes most sense for them in the ecosystem. We provide ETL modernization services as well as proprietary systems and databases as also part of the ecosystem and reducing the workload. So you see software contracts, the cost reducing as you do that because you're moving workload off of these systems into Hadoop. Once we move the applications, we also provide support so that organizations have a opportunity to learn from us. We provide the complete transition services and training services as well. So it's more like a BOT model where we not only do we build it for you after the assessment, we operate it for you for as long as you want us to. We can continue operating forever if you like, or we can have a transition plan, and then we transition it to you and train you to make sure you are self-supportable and very comfortable with hanging on to it with the new technologies.
Great, Aashish. We have time for a couple quick questions. First, can Hadoop be leveraged to the cloud, and if so, are there any stability issues?
Absolutely. We are using it. We have implementations where we have Hadoop on the cloud, open source Hadoop on our cloud infrastructure, and there are methods available to make sure the data is really secure. You could use access nodes, or there are tools available that do it for you too. So there's many ways to make sure that the data is really secure, because that's one of the top concerns that organizations sometimes have. And that's where we also bring that to the table, all that knowledge and experience we have learned and earned over time to make sure your systems are really secure and stable.
Big data initiatives are usually large implementations. How long before one can get to production?
Yeah, that's a really good question. Oftentimes people think that big data means big implementation and big investment. That's really not the case. Again, that goes back to the lack of awareness. For those who are starting as an experiment with a small 8-node cluster and not having the skills, because it goes back to having the skills and having the experience, those who have learned the lessons. So, for instance, it took us years to get where we are. It took us a year before we got to a really, a good large size cluster. But we believe that within 3 months, we can have your production up and ready. 3 months. So that's a fairly reasonable time to prove the ROI and making the case in the organization with the proof of concept. So a POC for a 3 months duration can help you build a case and show some real savings, as well as building the organization agile.
All right, one more question here, Aashish. Do MetaScale offerings cover commercial distribution such as Hortonworks and Cloudera?
We do have one of the things we talked earlier about was the implementation cost, right? So it depends on the organizations. We are very flexible with what services and organizations or the enterprises will have. Hadoop is open source. You don't really need a lot of infrastructure costs to set it up. So if you are looking for a POC that should be relatively inexpensive, then it's very much possible. You can use commodity hardware. You don't need a very expensive appliance or infrastructure to do it. Same way you can download Apache Hadoop, which is open source. But we help you in that decision making and walk you through the whole process.
All right, thank you very much, Aashish, and thank you everyone else for attending. Just want to direct you to our final page. You feel free to contact us for more information, and we weren't able to get to every question, so if you want to reach out to us at contact@metascale.com, we'd be happy to answer those and any other questions you have. Also, be sure to visit us at metascale.com. We have information there about our upcoming Hadoop developer course. We have one scheduled in Chicago next week. Also, we have some white papers available, including one on ETL modernization and mainframe migration. And with that, thanks everybody, and thank you, Aashish.
Thank you, everyone.